Hello all. Hello all and welcome to this video on exercise 6G where we're going to look at solving cubic inequalities. This is a fairly quick video. It's literally just the one example. It's using all our skills from the previous topic where we just looked at graphing inequalities. We've got to be able to accurately graph inequalities. If we can graph them, then it's quite easy from the graph to solve the inequality. So let's have a go. We have this inequality x cubed plus 3x squared minus 4x is less than 0. So we need to find when is x less, or when is this inequality, okay, less than 0. So we can think of when is y less than 0. Okay, so that's what we should be thinking and what we'll move to when we go to looking graphically. So our steps are to graph, okay, or actually, sorry, we need to factorize to be able to then graph, okay, and then using graph solve the inequality. Okay, so that's our three main steps: factorize, graph, and then use the graph to solve the inequality. Now, factorizing itself, okay, has a couple steps to it. Okay, are we going to use long division? Are we going to use equating coefficients? How are we going to go about it? How do we even start by getting a factor? Okay, so a couple things that we need to remember is the factor theorem, and also then using a factorization technique, whichever one you choose. Technique. Okay, so first off, let's try and find a factor of x cubed plus 3x squared minus 4. It's got a negative 4, so I'm going to assume 1. So let x equal 1. We'll substitute that in. It follows on that we get 1 cubed plus 3, 1 squared minus 4. That is equal to 0. Therefore, x equals 1 is a solution. 2 of x equals 0. Okay, so that's our solution. Therefore, we get x minus 1 is a factor. Okay, so we're going to get x minus 1. I'll actually write this above. X cubed plus 3x squared minus 4, okay, is the same as x minus 1 factor. We're then going to get x squared plus bx plus c. Okay. And I know there's no a term here in front of the x squared because x times by x squared gives me my x cubed. There's no coefficient there, so I can leave that. From that, I could then say it follows on negative 1 times c. So negative 1 times c must be equal to my negative 4, okay, because that's the only constant times by the only constant. That constant times by that constant gives me the only constant. So I'm just using equating coefficients here. So we get c is equal to 4. Okay. And we also know, okay, if we do bx times by negative 1, so we're doing that times that, and also, what's that? C times the x plus c times the x, that is going to be equal to 0, okay, because that is my x terms, okay, x times c, that gives me cx. It's going to be equivalent to the x terms, which there's none up here. Ooh, wrong color. Okay, in my equation above there is a 0x term, so it's equal to 0x. So we get negative bx plus cx is equal to 0x. And we know c is equal to 4, so we get negative bx plus 4x is equal to 0x. So we get negative bx is equal to negative 4x, so b is equal to 4. Okay. So from that, we now have x minus 1 x squared plus 4x plus 4. Okay. We can also say that is equal to x minus 1, and we're going to factorize this quadratic in the second bit of it. Okay, add to give me 4, multiply give me 4. Well, that's easy, that's plus 2 plus 2. Okay, so that is equal to x minus 1 x plus 2 all squared. Okay, so we've done our factorizing. So we can now rewrite this problem. Now that we've factorized it using equating coefficients. We have x cubed. We can say x minus 1 x plus 2 all squared is less than 0. Okay. Now this is a repeated root cubic. Okay, so let's plot this. So we get x minus 1, so that's going to give us an intercept at x equals 1. So we get 1, 0, and we have another repeated root at negative 2, 0. Okay, it's repeated root because of that one there. Okay, we also know that this is a positive quadratic because cube term is positive. That means it is going net up. Okay, net positive gradient, this cubic. So it's going to have a repeated root by touching and then go through something like that. So we have our graph. Now here's the question. It wants us to identify when all of this is less than 0. So we can think of when is y less than 0. Well, that's really obvious. Okay. All through this zone, y is less than 0. And all through this zone, it keeps going on. Okay. My y value is less than 0. Okay. So when does this occur? Okay. Well, we have x needs to be less than 1, okay, because that's this change here. Okay. And interestingly, you need to pay attention to this other repeated root. It's asking for when it's less than 0. What is occurring exactly at this intercept? At that intercept, x is equal to 0. So it's not actually part, y isn't less than, it's equal to. It's touching the x-axis. It's x equals 0. So therefore, it is not less than 0. So we get this, okay, and, okay, when x is less than negative 2. Okay. So when is y less than 0? Well, it's all of here. Keeps going on and on and on. So we could say x less than negative 2. Okay. And also, so I'm just using the union, okay, when x is between negative 2 and negative 1. Okay. And when we don't count, because it's asking for less than, we don't count the actual intercepts, because at the intercepts, x or the y is equal to 0. Sorry, that's not x equals 0. Y is equal to 0. Okay, it's not less than 0, which we are required. So that's how you do solving cubic inequalities. You graph them, and then you look at the graph and go, okay, when is, depending what the inequality asks for, when is my y value less than 0, or when is my y value greater than 0? And you have to be really careful with intercepts, because if it's asking for just less than or greater than, you don't include the intercepts. Now, if it had an included sign in here, had something like that, well, then you do get to include the intercepts, and then that makes it a bit easier. But in this question, it doesn't. If you have any questions, please let me know on Edmodo or on Compass. Thank you very much.